this lecture 31, and in last couple of lectures we have been discussing about the steady state analysis of circuits which are excited by sinusoidal voltage source. And we showed you how to calculate the current. You have to find out the complex impedance, and if the input voltage is known, express it in phasor notation, divide that with Z, you will get current. And after getting the current, the question is how to calculate the power consumed by the circuit. I showed you that it is equal to V I cos theta. Mind you, this V is the RMS value of the voltage, I is the RMS value of the current, and cosine theta is called the power factor of the circuit. And also I told you in the last class the significance of having a low power factor or a high power factor. From the supply authority point of view, power factor of the load should be very close to unity. Nothing is better than unity, that is fine, because whatever volt ampere you draw from the source B into I, just this product of these two, only a portion, because cos theta being less than 1 is being utilized by your circuit, and based on that you have to pay the electricity bill. But for large industrial consumers, supply authority will insist that you maintain the power factor close to unity. Maybe it should be always above than 0.8. Otherwise, they have to also pay for the reactive power drawn by the load. Reactive power, as we know, is the power which is oscillating between the source and the load. So, that power is never consumed by the circuit, but nonetheless it puts overhead on the transmission system, because current value will be then more. Okay. Now, today I will tell you how to calculate S, P and Q using complex algebra, and the way because this complex analysis why we adopted only, of course, for sinusoidal source I can do, we have adopted because of the fact V bar equal to I bar into Z. This is the important thing, which is similar to V equal to I R. This bar over this indicating they are all complex numbers. So, so if this is true, then I can do anything which I did with DC circuit analysis with V equal to I R. That was the idea, except that these are complex numbers. Now, similarly, while making power balance in an AC circuit, we see power consists of S is equal to P plus J Q. This is the thing. We can define a variable S, which is the S is the total power drawn by the circuit, including active and reactive part. Because of the fact, see, if you make a circle, a triangle, right angle triangle like this, if this is your S V I and this is the power factor angle of the circuit, then this must be P, this must be Q, because V I cosine theta is P and V I cosine sin theta is Q. So, for obvious reason this triangle is always helpful. And why this S, product of voltage into current, is called apparent power? It is simply because of the fact this power looks like to be the power of the circuit, but out of this only a portion V I cos theta is being utilized by the circuit. So, that is why it is called active or real power The other portion Q, which is V I sin theta, it is reactive power and it oscillates going to and fro between the source and the load and never consumed. Okay. And in my last lecture, I told you how to calculate active and reactive power for this simple circuit here. Okay. Now, I will tell you one interesting thing, that is by not new things, but how to compute this total power. This is total complex power, total complex power. Okay. For example, the same example, suppose the supply voltage phasor is 200 0 degree, the previous circuit only, and this was 6 plus j 8, no, last one 6 plus j 8. This is the circuit, this is the impedance. So, Z bar 6 ohm and j 8 ohm, we calculated this, and 6 plus j 8 200 0 degree. So, very quickly let me do it. Supply voltage is 200 0 degree, and your I bar we got it to be 200 0 degree divided by the impedance 6 plus j 8, and it came out to be 20 angle minus 53 degree, close to that. Is not? So, the impedance Z bar was 6 plus j 8 here, so much ohm. Now, once we get this, and do not forget to write the units, volts, this is ampere. So, I bar I get. Now, one way to calculate real power and reactive power separately, that is P will be P, which is a number, not a phasor. Real power is magnitude of the voltage into magnitude of the current into cosine minus 53 degree, whatever it is. Similarly, Q can be calculated as V I sin theta, like that I can calculate it. But instead what I will be doing, whether it can be calculated in one stroke using complex algebra. The rule for that is the I will say, see, this is the, these two terminals are the load terminals A and B, but I should be very careful while writing, and then so I will write complex power or total power, complex power supplied by the source Now, before you calculate this, show the polarity of the voltage and show the direction of the current. Otherwise, better do not try to write this, you will be in a mess. So, from this I see this source delivers power. So, complex power supplied, delivered by this source I am calculating. It will be equal to, suppose, S bar I say, and this will be equal to V bar into I bar star. This star means the complex conjugate. Okay. So, this you calculate it in this way, 200 0 degree is the voltage, and I bar is this, therefore, I bar star will be, only angle will change to plus into 20 into 53 degree. This is I star. So, this will be equal to 4000 and angle of plus 53 degree, which is of course 4000 cos 53 degree. How much it becomes these calculations? We calculated it. So, in using complex algebra you can write it will be 2400 and 3200. So, 2400 is not plus j 3200. This is the thing of which the real part will give you p. This is p, this is q. So, I will say that source is supplying 2400 this AS unit you write here volt ampere, then for P you say this is 2400 watt and Q the reactive power is 3200. This you write volt ampere reactive. This is how they are same, that is watt only, this is also watt, but to distinguish it from the real power people invent another term, use it reactive power. So, that we do not mix up the things. So, 2400 watt, 3200 watt. Now, the question is why you take I star, why not take V into I only and calculate these things. It is better to note that generally the voltage let in general the voltage phasor could have any angle. For example, its angle is alpha. It is not 0 degree, that is I am started counting my time when the supply voltage has a value V sin alpha, it was not crossing through 0. So, we have discussed this. So, this is the voltage phasor where alpha is the initial phase of the supply voltage with respect to reference where there is no thing here. Then if z bar is equal to z theta, where theta is the power factor angle, then you know then I bar will be equal to V bar by z bar is equal to V by z, and this angle will be alpha minus theta. This will be the thing. That is, if you draw the, if your reference is here, your voltage phasor was here already V, but my circuit this thing tells. So, this angle was alpha and the current phasor, if it is if theta is positive, theta if assume theta greater than 0, theta positive, then I am talking about an inductive circuit, is not impedance of an RL circuit, theta will become positive. So, your I phasor will be lagging the supply voltage, this is the thing I bar and this is power factor angle theta. You must understand this. So, this is the voltage phasor whose angle is this and this is I z, is not. Therefore, you see in this case if you calculate this, that is V I star. So, what is I bar? I bar with respect to this reference should be magnitude of I into this angle is alpha minus theta, is not. This is how your I bar should be coming in your calculation. Okay. Now, suppose you say that I will calculate V bar into I bar, I will just multiply these two. If you do that, you will get V angle alpha into I angle alpha minus theta. This is what you will get. which will be giving you something like V I, this angle will be, if I make a mistake, point out. So, hopefully, I am doing this is like this, it will be. So, you see V, its real part will be V I cosine 2 alpha minus theta, and its reactive part will be V I sin 2 alpha minus theta. But the power, real power, I know it should be equal to V I cosine theta only, that should come, angle between voltage and current phasor. Therefore, this will be this real part of V I does not give you neither P nor this Q will obtained. This is not equal to P, not equal to Q, something else you are getting, that is of no value to us. But you see, if this what I do, then I calculate S, the complex power, as V bar into I bar star, and I say that this is V angle alpha, this phasor is V angle alpha, this is my reference line with respect to that. That is, the supply voltage is sin omega t plus alpha, supply voltage I am describing it as sin omega t plus alpha. Therefore, this will be the thing, and then I bar is this. So, I bar star will be this one, I angle alpha minus theta whole star. So, when you take the complex conjugate of a complex number, only angle gets in polar form, only angle gets reversed. So, it will be V alpha, and this will be I angle theta minus alpha, this will be the thing. And if you multiply these two, it becomes V I angle theta, and I am now very happy, because its real part is really P V I cos theta plus j V I sin theta. So, never multiply V into I and say that that is your S. No, I star you have to take. That is the convention followed by everybody. Therefore, henceforth what I will do, in a circuit, voltage phasor will be known. In general, it could have any angle V alpha, which I was doing for 0 degree, but it does not matter. Z is there, so current is V by Z, you go on calculating like this. But while calculating power, complex power in this circuit, do this thing, voltage into complex conjugate of the current phasor. Then its real part will give you real power, imaginary part will give you imaginary power. So, coming back to this circuit here, this is exactly what I did, V I star I did. If the reference phasor is alpha equal to 0, then of course, one can do alpha equal to 0, same thing you will get, but better do not do that, because there may be situations when it is having general angle supply voltage. So, this is how P and Q can be calculated. So, what I wrote, power delivered by the source is this much real power it is delivering, and this much reactive power it is delivering. Similarly, in language I will write complex power absorbed by the source by the load. Here load terminals are these two, and it will be equal to voltage across the load V bar A V into I star. VAB is same as supply voltage. So, 200 0 degree into I star, same calculation. In this case there is no difference, 53 degree, and you will get the same result, that is 24 watt plus J 3200 volt ampere reactive. This will be the thing. That is, in AC circuit, sinusoidal excitations in steady state, the power balance should be true both for real power as well as for reactive power. Whatever real power is supplied by the source, supplied. It was 2400. What is the real power absorbed by the load? 2400. What is the reactive power supplied by the source? 3200. What is the reactive power absorbed by the load? 3200 var, volt ampere reactive. Now, it is such a simple series circuit. So, what I will do now, I will, as I told you, I have solved a problem, and that I will work out here today. So, a typical problem, a problem, numerical problem. Achha, this circuit will be like this here. I have made a circuit, for example, here is the one impedance, which is called, say, Z1 is equal to 3 plus J4 ohm, and here is another impedance here, RC, whose value is 6 minus J8 ohm, capacitive reactance minus J8 ohm, and here is another branch which is R and L. Let this impedance be called Z2 bar, and let this impedance Z3 bar, which is once again RL inductive, 8 plus J6 ohm, and so there is series parallel combinations, and here is a source connected whose phasor representation of voltage, that is V S bar, is equal to 220 angle 0 degree so much volts. These are all in ohms. Okay. So, let this impedance be Z2 bar and Z3 bar. Obviously, I will first calculate this current. So, this example, so this current is suppose I1 bar. I1 bar will be equal to supply voltage, that is 220, hopefully I have taken 220 angle 0 degree, divided by equivalent impedance between these 2 points. See, since V equal to Zi, phasors maintain this relationship. So, all the things I did in DC circuit will be applicable, that is, it will be Z1 bar and the equivalent impedance of these two, that is plus Z2 bar, Z3 bar by Z2 plus Z3. This will be the current in the circuit, which if you put the, so I first, so this is equal to actually 220, I should have written this first, Z equivalent. For Z equivalent, this is the thing. Now, Z equivalent, if you calculate, use your scientific calculators, where you can very comfortably calculate the equivalent impedance. So, it will be put the numbers 3 plus J 4 plus 6 minus J 8 into 8 plus J 6 divided by sum of these two, which will be equal to 14 minus J 2. And if you calculate it out, which I have calculated, hopefully I have not made a mistake, it will come out to be 10 plus J 3, so much ohm. So, Z equivalent being known, I will be able to calculate I 1 bar. I 1 bar is how much? I 1 bar will be equal to 220 0 degree divided by this 10 plus J 3. And if you calculate this, it will become 21.07 and angle will be minus 16.69 degree. So much ampere. So, this is I 1 bar I have calculated. Now, what I will do is this, I will these terminals I will name them. So, that now to calculate these currents in this branch and in this branch, that is this is suppose I 2 bar, directions are very important, just like DC circuit you allot directions. So, I 1 bar will be this, then I 2 bar, the current drawn by Z 2 will be, you can apply the division of currents in parallel circuit, that rule, that is it should be equal to I 1 bar into other impedance Z 3 bar divided by Z 2 plus Z 3, and put these numbers. I 1 is known. So, 221.07 and angle minus 16.69, and this into, in the numerator it is Z 3, Z 3 is 8 plus J 6 divided by sum of these two is 14 minus J 2. And if you calculate this as per my calculations, it was coming as see, generally calculator will give you rectangular form, but you can easily convert it to polar form, which gives you 14.89 and angle is 28.31 degree, close to this it will come. So, this is equal to I 2 bar, so much ampere. So, I 1 is known equal to I 1 bar, I 2 bar. Then once again I 3 bar can be calculated, but I have calculated it in this way. I 3 bar, because KCL has to satisfied, will be equal to I 1 bar minus I 2 bar. I have calculated it in various ways, so that you understand in with phasors KCL is also satisfied at the nodes. Therefore, it will be I 1 bar minus I 2 bar, I 1 bar is 21.07, this one is I 1 bar minus angle 16.69 degree minus it is 14.89 and angle is 28.31 degree. And if you calculate it out, it will be equal to I 3 bar will be equal to finally 14 point in polar form 89 and minus angle 61.65 degree. You also calculate, most probably I have not made a mistake, but who knows. So, this is equal to I 3 bar. So, all the currents are now known, I 1 bar, I 2 bar, I 3 bar. Across each of the elements there exists some voltage. For example, across the source, source polarity must be also told, plus minus. Okay. This impedance Z 1 bar lies across A B, and Z 3 and Z 2 they are in parallel, they exist across B and C, that is fine. Now, what I want to tell you is that I would expect that source is supplying a complex power to the circuit, real and reactive power. So, I will calculate that first, that is I will calculate what is the power complex power, it other complex power supplied by the source, it will be equal to current is coming out from the positive. So, I should take V s bar into I 1 star, that is what I have to do to calculate the power supplied by the source. And this is known, V s is 220 0 degree into I 1 star. Here you should be careful, this is I 1, its angle is minus 16.69. So, it should be 21.07, then angle you flip, if it is minus, so it has to be plus, complex conjugate, is not, that is what you have to do. And if you calculate it, its real part will be something like 4, I will use a different color. For example, its real part will be 4393.76, real part, so much watt, plus reactive part will be J. I hurriedly calculated, but you please cross check this, 1331, about 0.25, so much volt ampere reactive. This is the power supplied by the source. This point is important and you calculate it. Okay. So, this is one result. Then what I will do is this, I will calculate what is the power absorbed by Z 1, what is the power absorbed by Z 2 and what is the power absorbed by Z 3. Each one of them, since each one of them is having some energy storing elements with them, I would expect that each one of them will absorb both real and reactive power. So, sum of all the real power should match with this, or sum of all the complex power will eventually will come out to be this. This we will see, we will continue with this calculations. Okay. Thank you.